missing here that I'm not going to fill out. Okay, and it's this part. See how you don't have this chart? You see that? Okay, I cut that out. It's good, but I can make the same points with the unit circle just here, and then I'm going to go backwards. You know, and then you can look at the key, or if I look at the clock, I'll look at the key of the notes and show what the point they're making with it, which you know you do have to have in your head. But I just don't think we have the time to write all this. So that was my overall issue: paper and time. Okay, two things. All right. So first thing we're going to do, we're going to piggyback off this and continue. And then when we get to the unit circle, I'll ask those same questions. What's an over 6 in radians? What's an over 4? What's an over 3? But we really got to be not fractionally challenged. Sorry, I just realized I was in the wrong document there, wrong program. When you're dealing with a radian, and I've discussed this before, we don't have to make that determination now, but what we do have to do is do what's called a reference angle. Well, not yet. Sorry, I jumped ahead of myself. Co-terminal. So identify one positive and one negative co-terminal. What's co mean, everyone? Same, and then terminal, end. Same end. So the angles have the same end as what this angle does. All right. Identify a statement of all angles coterminal. Nice. Using n. This is good. If the angle is quadrantal, state it. Remember, I used that term yesterday. Quadrantal means you land on an axis. Correct. Otherwise, state the quadrant that each angle terminates in. Okay. So where does 5 pi over 4 land in? Well, I guess we could do A first. What's a coterminal? Well, I really feel like we should know C first. Where does 5 pi over 4 land? What quadrant? This is what I always do with my students. Don't answer it yet. I always do this. This is for the A-Bers especially too. And then help them. What is that? What is that angle measure? Just tell me what it is that you know. Okay, no more 180s. We're going to get away from angle measures and degrees for a minute. That's pi, which is 4 pi over 4. Right? Where's 5 pi over 4 then? What quadrant? 3. That's how you do this. I don't know why students will have a problem with this in the AB class. They just can't do a fraction, maybe. I don't know this yet with my crew, but every single dang year, radians are like doing calculus. And it's because of fractions and not understanding the simple components right here. Now I'm going to jump backwards. How do I write coterminal angles to this if this is 5 pi over 4? Well, one way that's negative is just to go directly that way. What is that then? 3, 2, 1, go. Negative. Anyone? No, it's not. He keeps doing degrees. I'm going to go crazy. All right? It's got to be in radians. All right? So what is it? Negative. Why is it 3 pi over 4? What is 3 plus 5? What is 3 plus 5? Oh my gosh. Get your calculator out. No one could answer that. 3 plus, oh, it's 8. What's 8 pi over 4? 2 pi. So these should represent 2 pi, compared to each other when you add them together without a negative. Good start, class. All right. And then how can I get a positive coterminal? I could do this. I could go 1 revolution and then that move. What do I have to add to 5 pi over 4? 2 pi, which is 8 pi over 4. This is fun. What's 8 plus 5? Get your calculator out. I have to be this way because they're all looking at me. Some of them are drooling. I don't know what's going on. Everyone okay? Have I made any mistakes? You wouldn't tell me anyway. You got mentioned on the video. I think I had to make a video the next hour. And I mentioned your name. I said Kurt. Kurt didn't tell me. Just sat there and anyway. Okay, so how do I name all angle measures with this little n thing? And I think it does say n represents all integers. What are integers, by the way? Are they fractions? No. No, actually, that's enough. All right, rip off a Band-Aid. No, it's not. All right, and then are they negatives? Are integers negative? Yes. Oh, no. So we don't know our integers. Here's the subset of integers. Dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, 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 dot. That's what integers are. Non-fractions, non-decimals, including 0 and negative numbers. Okay? So if n is an integer, then how do I name all of these angle measures that land here? Well, the angle measure, and then how far away is the next angle measure? What would I have to add or subtract to 5 pi over 4 to get that? What would I have to add to 5 pi over 4 to land right in the same spot? If you say 360 degrees, I'm going to throw a podium. 2 pi. This is not degrees. And then n. Why? N could be 0. If I plug in 0, what angle measure do I get? Just say this one because it's not going well right now. 5 pi over 4. When I plug in 1, what angle measure do I get? Just say this one because it's not going out well right now. When I plug in negative 1, just say this one because we got to move along. And then if I throw in 2, that's another revolution away. 3, that's another one. Negative 2, that's another revolution. All right? So we got to know this in the future. This is going to be a huge deal, knowing how to write expressions for all answers. Okay, and that should hopefully be clear. All right. So what's A? Let's do A before we do C anyway. So what do I have to subtract from 14 pi over 3? 6 pi over 3. Why 6 pi? What 6 pi over 3 represents? 2 pi. So what is 14? I guess I could help to graph this. But when I do this, oh my gosh, what's 14 minus 6 pi over 3? What does that become? 8 pi over 3. Is that still more than one revolution? It is. So I'll subtract another one. What do you end up with? 2 pi over 3. So here's 14 pi over 3. Here's the graph of it. 1 revolution, 2 revolutions, and then 2 pi over 3. So I could have done 2 pi over 3 as a Fettermac. Let's do that. Because it said 1 positive, 1 negative. So I decided to subtract 2 pi's out of there. 8 pi over 3 would have been a correct answer to satisfy the directions. I need 1 positive and 1 negative. And then what would this angle measure be directly from here to here? Come on, this should be faster now. That should be negative 4 pi over 3. I'm not getting a lot of people answering that, which is a signal that we are struggling. Or, you know what I could have done? Subtracted yet another 6 pi over 3 away. 2 pi over 3 minus 6 pi over 3 is negative 4 pi over 3. All right? Okay, a little nervous. All right, now, how can I name all the angle measures? This is a choice. You could pick any of these answers. You could pick 14 pi over 3. You could pick 8 pi over 3. You could pick 2 pi over 3. You could pick negative 4 pi over 3. But what I will do is take my original, just to not confuse. And then why plus 2 pi n? Because n could be a negative. N's an integer. If I plug in negative 1, I get 8 pi over 3. If I plug in negative 2, I get 2 pi over 3. If I plug in negative 3, I get negative 4 pi over 3. If I plug in 1, I get the next one later, which is 20 pi over 3. Right? I hope we're all okay. All right, and then we already know what quadrant. What quadrant are we in? 2. So we already got that from doing a drawing of 14 pi over 3. Okay. Hey, what is this called? Starts with a Q. We're running out of time here. Quadrantal. Okay, anytime it ends in an over 2 unreduced or reduced all the way. When it's reduced and over 2, we either top or bottom. So how do I get a positive? Well, what do I keep adding? 4 pi over 2. You know what? That could be our first negative. That's negative 3 pi over 2. Now I know where that's at. I add another 4 pi over 2, and I got pi over 2. These are two coterminal angle measures. When I graph them, I guess I could put the graph, it doesn't really matter. Here's what negative 7 pi over 2 is. It's clockwise one rotation, and then clockwise another 3 pi over 2, which means pi over 2 is the positive angle measure that lands in the same spot. So this is the one. If it's quadrantal, state it. So we put that this is quadrantal. Quadrantal. There is no quadrant it lands in. And then I skip B. That is just pick any of these. Oh, maybe just go with the original. -7 pi over 2, but it could have been any of these plus 2 pi n. You're going to have to do this a lot when we get into later stuff. All answer possibilities. All right, I feel like this, okay, fine, I'll do this last one, but we'll just kind of reference this, like how this is created from this. They're really intertwined with each other. They really should be on the same page, I think, too. I'm not judging, just saying. Where's -7 pi over 6? Try to tell me what quadrant that lands in. We are going to have to do this fast. So 3, 2, 1. What quadrant is it? It is 2. Here's why. This is -6 pi over 6. So this is -7 pi over 6. It goes a little bit farther. I don't understand how students could see this as being difficult, this thing right here. This is why I get kind of a little saucy during the notes. Is that a word that people use? I don't know. No? Get a little, I get a little agitated about students saying things are hard when they're not. It has nothing to do with pre-calc. It's what you came in here with, right? Add 12 pi over 6, correct? And what do you end up with? 5 pi over 6. And then you're supposed to subtract 12 pi over 6. That's -19 pi over 6. Got it? So then what's B? You take any one of these three. It doesn't matter. Take any one of these three. It's plus 2 pi n. That gets me the same angle, the same position where I was. That's literally what I did to find these coterminal angle measures. Okay, and I feel like this is out of place. We would have to look at this first before we do this, I think. And that's why I kind of was covering that. All right, and then reference angles. Good. So we are going to talk about that. Didn't we already create this though? Kind of, right? Right. Like for instance, and I'm going to use colors. If you have a highlighter, you might want to highlight at this point. These positions are for your angle measures in degrees. What's 30 degrees? What was the radians? Pi over, we already covered this, pi over 6. Now we are going to do this thing. I don't know if I'm supposed to let you create this yourself, but we are kind of limited on time. Oh my gosh. Are you serious? I don't even remember Wednesday, what time we get out. What? It's like an eternity. 25 minutes? Oh, you gonna make it? I don't think so. All right. Okay. Here's what we did with this. This is probably the only triangle I can draw. Maybe I'll do one in quadrant 2. We're gonna draw our triangle that I told you about, and then that means this reference. Okay. On the net after this, they do talk about reference angles. That's the reference angle. This is where we play SOHCAHTOA with, okay? And I do want you to draw this one triangle in this one quadrant. I may draw another one in another quadrant here, and then a third one here to represent all three different ones. So this side is, what side is this? What side is this? We have to have it memorized. 1. What side is this? What side is this? √3. And then what side is this? 2. But this is called a unit circle where the radius equals 1. Now we're going to do it, and I actually already referenced this. How do I make this equal to 1? I divide this by 2. And because of proportionality of similar triangles, all the sides can be divided by 2, and I'm good. So now that this is a unit circle in here, it's this that goes in here. This is √3 over 2 now, comma 1/2. Got it? Okay, now what I was going to do is do this. I was going to go ahead and maybe let's fill in all the 30s. So this one right here, this is 30 degrees this way. So what is that as an angle measure in degrees? 100 what? 50. You're 30 degrees short of 180. And I am going to keep these red. I'm going to fill in all the reds. What is that in terms of radians? Well, this is 6 pi over 6. Jump backwards then. What is this in radians? That's how easy it is. You tell me this is difficult, you make me infinitely and totally sad. Hey, jump forward 30 degrees. What is this then? I'm sorry, wrong. What is jump forward from 180, 30 degrees? What do you get? 210. You're a little too slow on these answers. We need to speed this up. Jump forward from 6 pi over 6. What do you get? 7 pi over 6. And then go to here. This is 2 pi, which is 12 pi over 6. Jump backwards. What's that? Jump backwards. That's 11 pi. I did the radian first. What about the degrees? Jump 30 degrees. That's 330. I heard someone whisper it. Those we'll do in red. Okay, then you know what happens with these coordinates? Don't draw this triangle. But the triangle is exactly the same. Don't draw this because I want to draw the other different one in there. This is still 1, root 3, 2, liar, right? Left and up, but then divide by 2. So this is not, did I miss? Okay, no, okay, I'm looking up here, sorry. This is not root 3, it's negative root 3 over 2, comma half. So it's the same coordinates, and that's what they were trying to do with this. They were trying to get the chart filled out and notice the same coordinates. But I don't know how you do that without a triangle being shown in, in our first. And you're not new to this. You're not new to this. I don't think I did unit circle with you guys though as much. I didn't have you memorize all these coordinates last year. All right, and now you get the idea. What happens in quadrant 3? What are both x and y? Negative. So it's the same coordinates, but it's negative, negative. And then in quadrant 4, it's positive, negative. Didn't that first bell already ring? Right? So I don't know if you're going to be able to memorize this or not. That's part of the deal here. Now I'm going to change colors. If you have pens, change colors. If you have highlighters, change colors. Now I'm going to go to the next one. What's the next one? That's okay, fine. It's the 45 degrees. What was that? Pi over what? Pi over what? 4. Okay, I'm going to jump over here. What's 45 degrees short? I'm going to draw this one. Go ahead and draw that one. Now we're going to draw 45 in here. And then in the third quadrant, we'll do our 60. Okay, just to see what happens. What happens with that? Well, what did we say these sides were? Didn't we say 1 and 1? And then what's 1 squared plus 1 squared square roots? Square root of 2. Wait a minute, one of these are wrong. Which one's negative, the bottom one or the top one? This is coordinate trig, so that's a coordinate that's got to be negative. Okay, but this is a unit circle, so what do I have to divide everything by? Root 2. So this is root 2 over 2 negative, comma, root 2 over 2 positive. So guess what this is? Positive, positive. Same triangle, same ratios. Right? AP doesn't care if you left it as 1 over root 2. We did find out they don't care much about rationalizing. Okay? Oh, and then what's 45 degrees backwards? What does this angle measure in degrees? 135. What's the over 4 when this is 4 pi over 4 and I jump backwards? 3 pi over 4. So now let's continue to fill this out. What happens when I jump forwards? What is this? 5 pi. Only one person saying it. What happens when you go 45 past 180? 225. And guess what these coordinates are? Negative, negative, same things. Why? Because it's going to be the same triangle. It's just coordinates. I have certain things that are negative and some are positive. And then what's 45 degrees short of 360? What's 45 degrees short of 360? 315. Okay, well, now I have to put this up here. What's short of 8 pi over 4, which is 2 pi? What's short of 8 pi over 4? It actually angers me, students saying that this is hard. Angers me, okay, because it's not. Right root 2 down. Now, memorizing, yes, you're going to have to, but, through just doing your homework over and over again, these ratios should come about. They should really be fine. All right, and then the last one, we'll do blue, and we'll do the 60 in quadrant 3. Yeah, I'm going to have some run over no matter what. So the 60 in quadrant 3 ends a little bit short. Maybe I can move that 1 over root 2 in green to the other side. Negative 1 over root 2 for the green one. Should have went purple. Okay, but anyway, this is 60. Green and blue kind of look very similar. Do they have the same base? No, what's green? Oh, yeah, green is blue and what? Yellow. We already talked about. Yeah, we did that yesterday. So I should have done purple, which is red and what is purple? Red and blue. Oh, and not green though. So it'd be a little bit different than green. Hey, what's opposite 60? No time. Root 3. What's opposite 30? No time. 1. What's opposite 90? No time. 2. But then what is this called? Unit circle. Oh, and I have one more mistake. Actually, 2. What are both of these ratios? Negative. So this is a flip-flop, not root 3 over 2, comma 1/2. It's 1/2, comma root 3 over 2. Negative, negative. Well, now let's go to this blue one. This is 60 degrees, and this is pi over, what is it? Pi over what? 3. Okay, we already made those determinations, and this will be 1/2, comma root 3 over 2. This will be negative 1/2, comma root 3 over 2. What's 60 degrees short of 180? I'm not caring about you answering anymore. What is short of 3 pi over 3? 2 pi over 3. What is bigger than 3 pi over 3? 4 pi over 3. And then what's 60 past 180? 240. And then over here, this I have to compare to 6 pi over 3. Short of 6 pi over 3 is 5 pi over 3. And then 60 degrees short of 360 is 300. And it's going to be 1/2 positive. My brain. Negative root 3 over 2. So again, you know what? It's all students take calculus. So you can almost insert that in there too. ASTC. And look at this last one. Well, I mean, I guess that's kind of weird because we're not talking about trig yet. So, but it will incorporate that. And I will tell you this: all of these coordinates are in the form cosine, comma sine. Put that up there because it's true. What's the sine of this 30-degree angle? 1/2 over 1. 1/2. Sine. What's the cosine of 30 degrees in quadrant 1 or pi over 6? Root 3 over 2 over 1. The x coordinate. So all of these coordinates we have here are cosine, comma, sine. If you can remember those. All right. I was never a big memorizer of the unit circle. I've done it so long, though, a sine of 30 degrees is what? So then what's cosine of 30 degrees? Not 1/2. It's the other one. What's the other one? Root 3 over 2. So what's sine of 60? Well, if sine of 30 is 1/2, what's sine of 60? Root 3 over 2. So then what's cosine of 60? 1/2. If you remember sine of 30 is 1/2, then 30s and 60s should be done. What's sine and cosine of 45 is always? Root 2 over 2. Now the last thing is tangents. Tangent, you will find out, and I think you found this out last year, is sine over cosine. That is an identity. So how you find tan is you just take these fractions and divide them. What's 1/2 over root 3 over 2? The 2's cancel, it's 1 over root 3. What's 1 over root 3? Root 3 over 3. Look at 60 degrees. What's root 3 over 2 over 1/2? The 2's cancel, it's root 3. So that's how you deal with this unit circle. Oh, what time is it? I feel like we're not going to make it. Huh? I have 13 minutes. So I might have to just talk about reference angles and then get a couple of each section after that. Hey, what's this coordinate? We did this yesterday, 0, 1. Oh, whoops. That's supposed to be there. All right. I guess I should have done this purple because these are all different. I don't know. And then this is 90 degrees and it's pi over 2, right? And then this is negative 1, 0. And this is pi and 180. We know that. I shouldn't even have to fill these out. This is 0, comma, negative 1. And then this is, I forget which one's which. I guess radians are on the left. Degrees are on the right. Is that true? No, that wasn't true. Left, right. Oh, well. And then the last one, this is, why do we have 2 here? 0 degrees, 0 radians, but also rads, but also 360 degrees, 2 pi radians. That's why we have 2 positions there. And then that's 1, 0, which is probably where I should have started. Right? Okay. Now, I will tell you, I don't normally use this. I use sine of 30 is a half. And then I could kind of think about the triangle to get my ratios. Whatever you need to do to get these quick. This is definitely multiple choices, though. But let's do one more thing about reference angles. What are reference angles? The positive acute angle made with the x-axis in the quadrant that you're dealing with. So these are not on your unit circle. There are no over 5s. So where's 4 pi over 5 land, first of all? What quadrant do you think? It's definitely the second. It's very close to what? Very close to what? Pi. Why? Because what's pi? 5 pi over 5. So then what's this angle measure right there? What does that measure in radians? So if this is 5 pi over 5 and this is 4 pi over 5, what's left over? So this angle measure right there is actually a pi over 5 reference angle. Usually reference angles are given the notation theta prime, a little prime on it. It's the reference. So I will use the term reference angle. Hey, what's 7 pi over 6? It's a reference angle of it. I'll use degrees. What's an over 6, by the way? Automatically. It's a 30. And where's 7 pi over 6 located? 3. So then I know what signs I'm dealing with. So that's why the terminology is going to be used. Where's 9 pi over 7 land? Where's 9? That's close. Think about it for a second. Where's 9 pi over 7 land? 3, 2, 1, go. Third. Why? This is 7 pi over 7. And how come I don't know I know it's not in quadrant 4? Because 3 pi over 4, 3 pi over 2 is like 1.5 pi. So 10 pi over 7 would land in here because that's bigger than, isn't 10 over 7? Hold on, wait. I don't want to be a fool. No. Where would 10 pi over 7 actually be? It'd actually be here because 10 pi, that's 3. So it'd be 3.5. Yeah. So it'd be 10.5 pi over 7. Isn't that crazy? That's equal to 3 halves. Did you know that? The 7 is 3.5, right? 3.5, half of 7, 3.5. Yeah. So 10 pi over 7. So 9 pi over 7 is like right there. Okay. But what's the reference angle? It should be easy. What's that difference between this and this? 2 pi over 7 is the reference angle. Okay, that's the angle right there that we would use SOHCAHTOA on. Okay, and that's what we're just exercising. Okay, then what's this one? This one's easy. What's 5 pi over 3? What's the reference angle? Oh no, 2 pi plus 5 pi is 7 pi over 3. So what is it actually? No one said that. Not one person in this class said that. Huh? What's pi over 3 plus 5 pi over 3? 6 pi over 3. Here's 5 pi over 3, which is here. So this leaves pi over 3 left over to get to 6 pi over 3. We're bamboozled by that? Thought that would be a layup. Okay, rejected. Then where's negative 3 pi over 4 land, first of all? Where does that land? What quadrant? 3, 2, 1, go. Why 3? Because this is negative 4 pi over 4. So everyone should know what the reference angle is. By the way, reference angles are always positive. Okay, so what's this leftover angle if you're short? What are you short by? Pi over 4. Pi over 4 is the reference angle. You always state the reference angle as a positive. Everyone okay? People are making faces at each other. Okay. All right. So Now we're going to get to all this. I don't even know what all that says up there. I'm just going to do it. All right, we're just going to go. So here's your discount double check. I always have and use as an escape drawing the triangle. But I got to know a couple things. Number one is, what's an over 3? A 30 or a 60? There's only two choices. It's a 60. Where does 2 pi over 3 land? What quadrant? 1, 2, 3, or 4? 3, 2, 1, go. 2. It's because this is 3 pi over 3, so this is here. So this is a 60 in quadrant 2. Let that sink in for a minute, because you're always going off of the nearest x-axis. All right, this is what I did last year. I don't know what the best way is. The best way is doing your homework over and over again until these get memorized. Like, because you see these ratios over and over and over again. And I already know that an over 3 for tangent, I already know it's root 3. All right, it either is root 3 over 3 or it's root 3. That's what tan and cotan values are. All right, but the reason is this, and I actually get lazy with it. I don't even do the unit circle. I go back to my 1 root 3 2. I just do that because it's fine. And what's tangent? TOA. There it is. It's root 3 over 1. I have one mistake, though. Who's negative? Who's negative? 1. Is this, do you have space on the bottom, or is it, okay, if you have better space, fine, I'll put it here. The answer is negative root 3. Got it? So this is your discount double check. You don't have to use a unit circle. I can always go back to 1 root 3 2 and then just do SOHCAHTOA. Not on this one, though. 3 pi over 2, where does that land? Top, bottom, right, left. We played this game yesterday. Bottom. What's the coordinate that I have to stick in there? 0, comma what? Negative 1. And then what's sine? Sine is what letter over what letter? Y over R. Sir. So that's the other thing that you put up at the top of this. Sir, kicks or ticks. And you remember what that means in terms of that, because you need it for this one. SOHCAHTOA was fine for the first one. What time is it? I'm going to skip around here because I do have to get to the end. What time is it? 30. What do I have? 36? Okay, 5 minutes. I like these last two because where does 15 pi over 4 land? And I have, by the way, who's secant related to, sine or cosine? Good, because what's cosecant? Come on, say it every day. It's a hoe. All right, it's related to so. All right, so sine is so, cosecant's a hoe. That means secant goes with cosine. So we're going to be doing r over x or h over a if you wanted to do cos, because you are going to get a triangle here. Wasting too much time. Okay, what's a full rotation over 4? Blank pi over 4? 8 pi over 4. What's left over? 7. Where does 7 pi over 4 land? Quadrant what? 4. And it is 1 rotation, 2 rotations. And then if you wanted 1, 1, root 2, negative. See how fast that is? This is a discount double check. This is a way to just make sure if I don't have my memorization down. All right, and then what's secant? It's r over x. So the answer is root 2. Or you could do a whole, all students take calculus. You know you're in quadrant 4. Cosine's positive, so secant's positive, and then know your ratios. By the way, secant and cosecant of 45 is always root 2, because it's the flip of root 2 over 2. So that would be memorization. All right. And then the last one, really focused on the over 2s. Where does negative 11 pi over 2 land? 4 pi over 2, 8 pi over 2. How many rotations is that? How many rotations is that? 2. 4 pi over 2 represents 2 pi. 8 pi over 2 is 2 of those. What's left over? Those are taking too long. Where does this land? Top, bottom, right, left. Top. Because here's negative 3 pi over 2. Negative, negative, negative. Okay, then also one more rotation. Actually, 2 more rotations. Is everyone okay? I'm getting these faces like. What's this coordinate? And then ticks, but it's x over y. So it's x over y. I don't even need r, so what's the answer? 0. Okay, so I don't know if the other teachers are doing the draw the triangle method. It's always a backup plan until you get these memorized. Always. And then these are just more the same of do a couple things at once. But I want to, so you could do those, right? I just got to do that, do that, do that. How do I do this? You find the cosecant of 5 pi over 6, get that answer, and then square it. Got it? Just know how your order of operations work. And how do you get that? Based off what I just did on the previous set of notes. Got it? Okay, so we should be able to do this. I really want to make sure you understand this one. And let's go to this one. This is a rough one. And this is how I always do this. What's root 3 over 3? The same as 1 over root 3, right? 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 And then what's tangent? What letter over what letter? Y over X. And then I'm going to tell you right now, Y is the most important one. Y is opposite the reference angle. Always. Look at this. Y is always opposite the reference angle. Y. Reference angle. Well, this one doesn't really stick out so much. Y. Reference angle. Y. Y is always opposite the reference angle. So who is opposite 1? Is it 30 degrees or is it 60 degrees? 30 or 60? We're still pausing on this. It's 30. So this is a 30 in, hey, what quadrant is pi to 3 pi over 2? That's the third. What is that in radians? That's an over 6. And what's the one in quadrant 3? Not 6 pi over 6. No one said that. 7 pi over 6. That's how you do these. All right. So I knew we were short on the. Can you imagine if we filled in that chart? There'd be no way. As a matter of fact, as you're getting your stuff cleaned up, I'll show you what the chart looks like on your calendar. You can look at it. There it is. Do you think we would have time to fill that out? No, the bell just rang. All right, so I knew it. Not bad. Just it's tough.